All right, so in this video we're going to talk about multiplicity of a polynomial function. So when we're talking about the multiplicity of a zero, basically we're always going to be referring to something then that's in factored form. If it's not in factored form, we can't determine if there's multiplicity or not. But if it is in factored form and you have a factor that has an exponent, an exponent of m, and now the rule says that if we have the same exact, as long as we don't have the same exact factor with a different exponent, or one exponent smaller than the original, that's why they say x minus c to the m is a factor of f, but x minus c to the m minus 1 is not. Okay, so we would not, that's not going to happen, so don't worry about that. But that's just a caveat to the rule. But if we have x minus c to the m power, then we would say 0 is a multiplicity of m of f. And by the way, when you read that last line, there is a Samuel L. Jackson joke there, but this is a PG video, so I am not going to go there. I'll let you do that. But anyhow, the exponent is referring to the multiplicity. Remember, because what an exponent refers to is how many times you multiply a number by itself. In other words, if we have, like this first example, x minus 1 squared, that means that we have two of them. We have two of the same factors, x minus 1 times x minus 1. And instead of setting both of those equal to 0 and getting two of the same answer, I'm just going to say that one of the zeros is 1, and it has a multiplicity of 2. So there's two of them. Or for this other one, if we have x plus 4 cubed, well, that means that we have x plus 4 times x plus 4 times x plus 4. And I could set each one equal to 0 and solve, or I could just say, could do it once with x plus 4 and say that a 0 is negative 4, and it has a multiplicity of 3 because there are 3 of them. That's literally how simple this is. But, so as far as what do you need to write down, don't worry about writing down everything. If you just want to write down that x minus c to the m means that we're going to have multiplicity m of whatever the function is. Okay, so, or that c is a 0 with a multiplicity of m. I wouldn't even bother with the m of f. So I would just make sure you have that in your notes. So now what does that look like for the graph though? Think about a parabola. If we have x squared would kind of bounce off the x-axis at 0, 0. That's how you can think of it. So anytime it's an even power, even multiplicity, it's going to bounce off the x-axis. Here's what I mean. This one here, we would have 1 would be our X-intercept, but instead of going through that spot, it is going to bounce off of it. So that's what that graph would look like. Now if it's an odd exponent, it's not going to bounce off of it, because if you think about the x cubed function, and with x cubed, it's kind of like a parabola, but one of the branches, one of the sides, not branches, but one of the sides of the graph has been bent down. It still goes through the x-axis. So that's what's going to happen. Anytime you have an odd multiplicity, wherever that x-intercept is, it is going to go through it, and it's just going to be kind of twisted at that point. So if we have negative 4, so let's say this is negative 4, so we'd have a point there, and it's going to pass through. It's not going to be a straight line, so we're not going to just say, oh, it's like this. Nope, we're just going to make a twist in that line. But it'll still go through that point. So that's what happens is we have a bounce, and then this would be a pass through. That's what we're going to be looking for. So when it's an even multiplicity, we have a bounce. When it's an odd multiplicity, it's going to pass through the x-intercept. So make sure you get some of that key information there in your notes. And when you're ready, go on to the next slide here. All right, so let's look at this one. So this one, again, it's all in factored form, so you don't have to worry about doing too much work here. We're just going to set, well, the only work that we're going to have to do is for the Y-intercept. Remember, the Y-intercept, is when x is 0 and y is some number. That's the Y-intercept. So to figure out what the Y-intercept is, we have to put 0 in for x. So we would have 0 plus 2 cubed times 0 minus 1 squared. Obviously 0 plus 2 is 2, so we'd have 2 cubed, which is 8. And 0 minus 1 is negative 1, and negative 1 squared would be 1. So 8 times 1 is 8. So for this one, we would have the y-intercept when x is 0, y is 8. So if we were going to go to graph this, which is what we're going to have to do here in a minute. Let's say this is 4. We'll count by 4s here, so this is 8, just to make it easy. Okay, so there's our y-intercept is 8. So now to find the y-intercepts, that we get from the factors. Okay, so if we set x plus 2 equal to 0, we get x equals negative 2. And we'll say it's got a multiplicity of 3. And then we would have x minus 1. We set that equal to 0, and we solve that. We get x equals 1. And that's got multiplicity of 2. So if I put my x-intercept at negative 2, we have an x-intercept there at negative 2, and then we have an x-intercept here at 1. So what's going to happen at 1 is, so it's going to have a pass through at negative 2, and it's going to bounce at 1, because if you think about the end behavior, that's what the next part is asking for. Now, end behavior we usually get, or I'm sorry, we've always gotten when it's in standard form. This is not in standard form. Now you might think, oh my gosh, I have to multiply x plus 2 cubed and then take that times x minus 1 squared and get it in standard form? No. All you're going to do to get this, because again, we're not going to get this in standard form, all we care about is finding the leading term. What I'm going to do is I'm going to take from each set of parentheses the variable term, so the term here is x, and then cube that, well that's just x cubed. Multiply that times the other variable term, the x, and then square that because of what's outside the parentheses. So we get the x cubed and the x squared, and we multiply those together. When we do that, we just get x to the 5th. You add the exponents. Okay, so that tells me that it's positive, so the right side is going to go up. It's an odd exponent, so the left side is going to go down. So when I go to graph this, on the left side at negative 2, it's going to go down and to the left because it's at that x-intercept. It's got a multiplicity of 3, so it's going to bounce through there. So then I'm going to draw a line going up. It's going to hit this y-intercept, and when it comes down, it's going to bounce, and then it's going to come back up. So our graph would look something like that. So at that x-intercept, since the second one there, where x is 1, it's got a multiplicity of 2, it's going to bounce. And this one's going to be a pass-through. So at first, you might want to make sure you write these down in your notes. So that way you can remember that as you're graphing it, you want to make sure that you take that into consideration. All right, let's do another one together before you try one on your own. So for this one, it says we have these two factors, x minus 2 cubed and x plus 3 squared. So let's start by finding the y-intercept. So to find the y-intercept, remember, that's where x is 0, y is some number. Okay, that's your y-intercept. So if I put 0 in there for x, we would have 2 times 0 minus 2 cubed times 0 plus 3 squared. So we don't want to forget about that 2. So this 2, the only reason why this 2 is in here is this impacts the y-intercept. It doesn't impact anything else. So now 0 minus 2, well that's negative 2. Negative 2 cubed would be negative 8. 0 plus 3 would be 3, and 3 squared would be 9. Well, I can multiply those in any order. If I take 2 times, or if I take, let's just do negative 8 times 9, I get negative 72. Negative 72 times 2 would be negative 144. So our y-intercept here is going to be at negative 144. So when we're doing this on our graph, you can count by, I wouldn't do just, so let's just do this. Let's count by 100s. So like this would be negative 100. This would be negative 200. So we'll just estimate negative 144. If this is 150, 144 would be right about there. So there's our y-intercept. So now we're going to find the x-intercept. So the x-intercepts, again, we get those as our factors. Now 2 is not a factor. There's no x there with the 2, so we're not going to get an x-intercept from that at all. So instead of putting a big x through it, maybe I should just scribble it like this. So that has no impact on our x-intercepts. The only x-intercepts we get are from our factors, which is where there's an x. Now if it was a 2x out in front, then we'd set 2x equal to 0. But there's no x with a 2, so we just ignore that 2. So I'm going to set x minus 2 equal to 0, and I would get an x-intercept of 2. And since it's got an exponent of 3, we say it's got a multiplicity of 3. And so that's going to have a pass-through. And x plus 3, I'm going to set that equal to 0. When you do that, we get negative 3. And since that's an even exponent, oops, I can't spell, that was multiplicity. It's got an exponent of 2, so it's got a multiplicity of 2. Since that's even, it's going to bounce off that point. So let's graph those points. So we would have, use my blue to draw my lines. Okay, so let's graph those points. So we would have a x-intercept at 2. And an x-intercept at negative 3. So we have x-intercept at 2, and it's going to pass through that point. X-intercept at 3, it's going to bounce off that point. But now we want to figure out what's the end behavior. So now this time, we would have the x being cubed and this x being squared. And then we can go ahead and multiply by that 2 here. So we would have 2, and then we would have x cubed times x squared, which equals 2x to the 5th. So if we were to multiply all of those together, we'd end up with the leading term of 2x to the 5th. So what does that mean? Well, since it's a positive 2, the right side's going to go up. Since it's an odd exponent, the left side's going to go down the opposite direction. So on the left side, I find my left point here, that's this one. It's going to go down and to the left then. My point furthest to the right, it's going to go up and to the right. And remember, with that negative 3, it's going to have a bounce, and so down here it's going to just bounce off that, and then it's going to come down, it's going to go through here, and then we have a pass through there, so that actually worked out perfectly. So our graph would look something like that for this example. So I want you guys to try one on your own. I want you guys to try this last problem, and then we are done with these notes for lesson 2-3. So why don't you guys go ahead and pause this video. Please make sure you take in consideration that that is a negative. So that will impact your graph here in a little bit. So go ahead and find now notice also the order is different. At this time they ask for the x-intercepts and their multiplicities. They ask for that first and then the y-intercept. And then find the end behavior and sketch the graph. So go ahead, pause the video, and hit play when you're ready to check to see if you did this correctly. All right, let's see how you did. Let's start with the x-intercept. So the x-intercepts, I'm just going to scribble this out for the time being. So remember that negative 2 has no impact on the x-intercepts. That's only going to have an impact on the y-intercept, which we'll find in just a minute. So for the x-intercepts, I'm just going to focus on those factors. So if I set x minus 1 equal to 0 and solve it, I would get x equaling 1. And then that's got a multiplicity of 4. So that's going to have a bounce. And then at negative, well, let's start with x plus 3, set that equal to 0. When you solve it, you get negative 3. And at that point, you're going to have a multiplicity of 3. And you'll have a pass-through there. I'll just abbreviate that. So I have a pass-through at negative 3. Now to find the y-intercept, I'm going to need that negative 2 back. So I'm going to put 0 in there for x. We'd have negative 2 times 0 minus 1 to the 4th times 0 plus 3 cubed. So we'd have negative 2, so negative 1 to the 4th power. Anytime we have a negative to an even exponent, your answer is positive, so it's just going to be a positive 1. And then you'd have 3 cubed, which is 3 times 3 is 9, times 3 is 27. And when you do that, you get negative 54. So the y-intercept's at 0, negative 54. So if this is negative 50, we'll have negative 54 maybe right about there. Let's put our other x-intercepts in there. So again, we have x-intercepts at 1 and -3. So we'd have an x-intercept at 1 and x-intercept at -3. So now we got to figure out the end behavior. So to figure out the end behavior, we have a -2, an x to the 4th, and an x cubed. So I have -2, x to the 4th, x cubed. Now again, that exponent of 4 does not apply to the negative, so I've had people ask, well, wouldn't that make the -2 positive? A positive 8? Nope. That exponent only applies to the x. So we'd have -2 times x to the 4th times x cubed, which when you add those exponents, we get -2 times x to the 7th. So that would have been our leading term there. So now to figure out what that means as far as the end behavior, since this is negative, the right side of the graph is going to go down this time. And since it's an odd exponent, the left side is going to go in the opposite direction. So this time, the left side is going to go up and to the left, and the right side is going to go down and to the right. So remember, on the left side, we should have a pass-through. Let's just double check here at -3. Sure enough, we have a pass-through, so it's going to come down. And then it's going to be really steep here. And then it's going to hit that and bounce off and then come back down again. So the graph would look something like that for number 9. So sometimes you get some funky looking graphs. That's okay, and it's especially funky because our x-axis and our y-axis, the scales are not the same, because I counted by 50s on the y-axis and I'm counting by 1s and have a pretty big gap there between the 1s. So yeah, that's why one of the reasons why the graph looks a little strange. But the key there is to understand how end behavior, how that all connects with these x-intercepts and this idea of if they bounce or pass through. So hopefully you have an understanding now of how to do that as well as the other parts to this lesson. And good luck now as you can finish your assignment by doing numbers 4, 5, and 6.